Black holes are the universe's way of saying fuck you to physics, right? So black holes, they're basically the Greta Thunberg of space. Everyone's heard of them. Nobody really knows what to do, and they're terrifyingly inevitable. Today, we're going to strip them down, see what makes them tick, and why they're basically the final boss of existence. And I promise, by the end, you'll understand them better than any sci-fi movie ever explained, which isn't saying much because most films get it embarrassingly wrong. So, what actually is a black hole? Well, it's a region of space where gravity has gone absolutely mental, so strong that not even light can escape. That's why it's black. Genius naming, really. To understand this, we need to talk about gravity and something called escape velocity. You know how when you throw a ball up, it comes back down? That's gravity being a clingy X, but if you throw it fast enough, it escapes. That speed is the escape velocity. Now, on Earth, escape velocity is about 11 kilometers per second. Fast, but doable. On a black hole, the escape velocity is greater than the speed of light, and since nothing can go faster than light, nothing gets out. It's a one-way ticket to oblivion. The point of no return is called the event horizon. It's not a physical surface, just the line where even light can't escape. Cross it, and you're done. Like crossing into your boss's office on a Friday afternoon. Here's a classic analogy. Imagine space-time as a really shit trampoline. Put a bowling ball on it, and it sinks. That's gravity. A black hole is like a cannonball that rips through the bloody thing. Everything rolls in, no coming back. Oh, how does one of these cosmic hoovers come to be? It starts with a star, which is basically a massive ball of hydrogen having a midlife crisis. Stars are a balancing act. Gravity tries to crush them, but the energy from nuclear fusion pushes outward. It's like a fat man in a crowded lift trying not to breathe in. But eventually, the star runs out of fuel. Hydrogen runs low and fusion stops. Suddenly, gravity wins. The star collapses under its own weight. It's like your grand souffle after a loud bang. If the star is big enough, like several times the mass of our sun, the collapse doesn't stop. It squeezes itself into a single point with infinite density. That's the singularity. And bam, you've got a black hole. If the star isn't quite heavy enough, you get a neutron star instead, which is still cooler than anything you'll ever do. But today, we're only interested in the show-offs. Right, so black holes come in different sizes. The basic ones are stellar mass black holes, weighing a few times the sun's mass. They're born from dead stars, and they're basically the chavs of the black hole world, common and a bit small. Then there are the supermassive black holes. These absolute units live at the center of most galaxies, including ours. We're talking millions to billions of solar masses. They're the fat cats of the universe. Milky Way's own supermassive black hole is called Sagittarius A. It's about 4.1 million times the mass of the sun, and it's just chilling 26,000 light years away. So if you're feeling sluggish, blame the gravitational pull. There are also supposed intermediate mass black holes, but they're like the middle children. We know they exist, but nobody really pays attention. Talk to me, when you've got a billion solar masses, love? Well, what would actually happen if you fell into one? First off, don't. But let's imagine, as you approach, you'd feel fine. Then you'd start to notice something stretchy. As gravity gets stronger the closer you are, your feet would be pulled harder than your head. You'd be stretched like a piece of gum. This process has a gloriously gruesome name, spaghettification. Yes, that's the scientific term. You'd be turned into a long, thin strand of human spaghetti. And before you ask, no, it's not recommended by Italian chefs. But it gets weirder. As you fall towards the event horizon, time itself goes wrong. From your perspective, nothing unusual. But to someone watching from far away, you'd appear to slow down, freeze, and then fade away. Relativity in it is because gravity bends space-time. The stronger the gravity, the slower time ticks. So if you fell into a black hole, the universe would fast forward outside. You'd see the entire future of the cosmos flash by, which is either profound or terrifying, depending on how you feel about reruns. But here's the kicker, you can't come back. Beyond the event horizon, all paths lead to the singularity. You wouldn't just die, you'd be erased from existence, so maybe don't book that trip. Crossing the event horizon is like sending a risky text. Once it's gone, except your entire body becomes quantum information smeared across space, which is slightly worse. Now, you might wonder, if black holes are black, how do we even know they're there? It's not like they pay taxes. Well, we see their effects on nearby stuff. A black hole is feeding, it pulls in gas and dust, which forms a spinning disk called an accretion disk. This stuff heats up to millions of degrees and glows like a damn disco ball. The innermost part of the disk gets so hot it blasts out X-rays, which we can see with space telescopes, so we're basically spotting them by their cosmic indigestion. Also, when two black holes merge, they literally shake the fabric of space-time. This sends out ripples called gravitational waves, which we can detect with incredibly sensitive machines like LIGO. Yes, we can hear black holes punching each other. The real piece de resistance, the Event Horizon Telescope. In 2019, they took the first ever picture of a black hole, specifically the supermassive black hole in galaxy M87, and it looked exactly like a blurry orange donut, a terrifying physics-breaking donut. They did this by linking telescopes around the world to create a virtual dish the size of Earth. Think of it as a giant, nerdy conspiracy to get a photo of the universe's most camera-shy celebrity. And it worked! We saw the shadow of the black hole against the glowing gas. So don't tell me science isn't magic. Here's the plot twist. Black holes aren't forever. In the 1970s, Stephen Hawking figured out that they actually radiate energy very slowly. So slowly that it's barely worth mentioning, but it means they eventually evaporate. This is called Hawking radiation. It's a quantum effect near the event horizon where particle-antiparticle pairs pop into existence. One falls in, the other escapes, carrying away a tiny bit of the black hole's mass. It's like shoplifting from a cosmic monster. For a stellar mass black hole, this radiation has a temperature of about 10 to the minus 7 Kelvin. That's colder than a snowman's nipples, so don't expect to warm your hands. But over an unimaginably long time, I'm talking 10 to the 67 years, the black hole shrinks and eventually pops out of existence. So even the final boss has a timer. It just takes longer than the entire history of the universe so far. At the end, there's a final burst of energy, like a tiny pop, and the black hole is gone. Poof! All that mass just evaporates. It's the most anticlimactic end for a cosmic horror. This raises the information paradox. What happened to all the stuff that fell in? Did it vanish? Is it somewhere else? Physicists are still arguing about this, and it makes them very, very shouty. Truth is, we still don't fully understand black holes. They sit at the intersection of general relativity and quantum mechanics, and those two theories hate each other, like a couple that really should divorce. So, black holes, they're the final boss of space. They break physics, eat everything, and then they evaporate into nothing. But they're also not the cosmic monsters pop culture makes them out to be. Sum it up, black holes are just gravity being a bit of a dick. They're extreme, but they follow the rules. We just don't know all the rules yet. They're terrifying, beautiful, and absolutely brilliant. If you ask me, black holes are the universe's way of showing off. Look what I can do. I can break your mind with a single object. Next time you look up at the night sky, remember, somewhere out there, a black hole is having a better day than you, and it's not even alive. Cheers. If you enjoyed that, like and subscribe, or the black hole will get you. Not really, but it might. No, it won't. Definitely, maybe. And remember, if you find yourself near a black hole, just relax. By the time you get close, the universe will have long since evaporated into nothing. So really, it's not your problem. Sum up, black holes are the ultimate hoovers, but they're also not all they're cracked up to be. They're just gravity being a bit of a dick. As always, thanks for watching, you magnificent bastards. See you next time.